Hi everyone, welcome to our second live broadcast. Hopefully everything is working fine. I will just verify it once more. So let me just see if it's working fine and then we can start with the challenge. So just give me a moment. Once more. So let me just see if it's working fine and then we can start with the challenge. So okay, so looks like it's working. Okay, so yesterday we saw Protostar Heap 0 and Heap 1 challenge. We saw how do we solve this, what is the heap structure and all. So in this uh, broadcast, what we are going to see is how can we solve Heap 2 challenge. So you can go to this website, that is exploit.education, and you can click on this Protostar and you can go to Heap 2 and you will see the source code over here. So first we will understand the source code. Then I have already compiled and uploaded a binary to my GitHub repo, which is over here, github.com hardik05 exploitation. If you go to this folder, then you can simply click on Protostar Heap and you can go to Heap 2. And it also has the solution if you want to follow along. So this is the compiled binary. This is I think 64-bit binary, which we are going to see. I have also uploaded the code over here. So one thing I can do is I can actually create a make file, or like I can give the compilation command as well, so that you don't need to like search for that. So that I think I will do after this video. But anyway, if you are planning to download this, then you can actually go to this git repo and you can download the compiled file. And I'm using WSL on my system. I have set it up over here. So let me clear the screen, and there seems to be some issue with the streaming. Okay, hopefully it's working fine. Let me know if there is any issue. So I will just verify it once more. Okay, seems to be good. I need to change some settings. Just hold on. Okay, I have changed the settings. It should be working now. Okay, so yeah, so let's start with our challenge. First thing we will do is that we will see the code of the C file. We can see it over here, or you can actually see it on the web. So here you can see that uh, there is a structure auth, and it has a variable which is of 32 bytes, which is called name, and then there is an integer which is called auth, right? So that's like authentication, and then we are creating a structure pointer to this particular structure with the same name auth, and then there is also a character pointer which is of service, which is called service, right? And inside the main function, if we see, we can see that it is actually having one variable, one array, character array, which is named as line, which is 128 bytes long, and then there is a while loop. So inside while loop everything happens. Now what will happen when we run this program? First time what will happen is that it will actually print a message like authentication pointer is this and service pointer is this, and it will basically print the address of this pointer, authentication and service. So service is actually a character pointer, authentication is a structure, and initially it will be null. So then it will like expect some user input, and based on user input we can see that it is having a lot of string and compare over here. Like there are 1 2 3 4, there are string and compare. So it will take the user input inside the line variable, which is of 128 bytes, and then it compares with various tags like if it contains auth followed by space over here, and it will compare 5 bytes. If it's matching, then it will basically do a malloc over here, so which is again the size of structure auth. So it will actually uh, allocate memory for this structure, and it will return the pointer, and it will set memory to 0. And then one more thing it will do is that if the string length of line plus 5, so if you see authentication, like this auth is 4 bytes plus 1 for space. So next to that, if there is some string, some data, and if the length of that is less than 31, so if it's equal to 30 bytes or less than that, then it will copy the name, that string, to the authenticate auth dot name variable over here, right? And then if it also compares the user provided input with another string called reset, so again you will see that it's comparing it by 5 bytes. So this is because the reset is 5 characters long, 1 2 3 4 5. So if it finds that reset is mentioned in user input, then it will actually call free. So what it will do is that it will free up the memory which has been allocated using malloc over here. So authentication is used to allocate memory, and reset is used to free that memory. This is something you need to note. Then we can also see that there is a string compare for service over here. So service is 6, I think 1 2 3 4 5 6. Is it 1 2 3 4 5 6 7? Actually it is 7 byte long, and here it's only comparing 6. Is it a issue? Yes, it's an issue, I think. But anyway, it should be 7 here and it should be 8. But anyway, that's fine. So if it finds service inside the user provided input over here, then what it will do is that it will call string dup, and it will actually take the character followed after service, and it will basically create a duplicate string for that. So we can do one thing actually. Let's search for what does string dup do here. So it will basically create the copy of the source, and pointer to the copy will be returned, right? So if whenever you call string dup, what it will do is that line plus 7, so whatever is following after service, it will actually create a copy and it will return the pointer, and that pointer will be saved inside service. So this is another thing which we need to note. And then what it will do in the file, it will also compare the user provided input with the login. So login is 5 character or 5 bytes long, you can see it over here. And here is what it will do, some checks. So it will first check if the authentication is set, and if authentication structures auth variable, if this is also set, then it will print a message that you have logged in already. But if this is not set, if like say if you directly give a command like say reset, or if you give a command like service, then it will simply print a message that please enter your password. So to solve this challenge, what we need to do is that somehow we need to make sure that we print this message, that is you have logged in already, and the condition for that is that our authentication structure has been allotted. So basically this malloc needs to get called, and then uh, inside that this authentication or auth variable over here inside that structure, it should be uh, set to 1. So if we see over here, by default it will be set to 0. So how can we change it to 1? That is the challenge. And the best thing to solve any challenge, the best way is to debug that and understand how it is working. So we have already seen the code, but in real life scenarios you will not have the code. You can use GitHub or IDE or binary ninja to decompile the code. You need to go through that, and you will actually see some function calls and all, and you need to trace the input. But in this case it is simple because uh, it's a very simple challenge. So I have actually compiled it, and if you want to compile it yourself, you need to disable all the flag or you need to disable all the exploit mitigation. So what you can do here is that you can use various, like I'm not sure if I have it over here. No, I don't think I have. So I will actually copy this compile command, but right now I have actually uh, have the compile file. So it's over here, and let's verify what file is this. So what architecture and all. So we'll use file command heap2, and it is actually a ELF 32-bit executable. So this is a 32-bit executable file, and then let's see if any of exploit mitigation are enabled. So we can see that by using checkset we can see it, and almost all the mitigation are disabled here, like stack is executable, there is no py, there is no canary, and uh, uh, yeah, everything is disabled in this. Now first thing we'll do is that we can simply run this and see what is the behavior of this binary. So okay, so it's simply giving this message, and it's trying to print authentication or auth pointer and service pointer, which is nil. So let's enter some garbage thing. Okay, nothing is working. Now let's enter auth, right, and give a space, and then we can see that it is giving us this auth pointer, right, and service is nothing right now. So let's enter service followed by 1111. So we can see that we can see the pointer for auth and service as well. So this is the basic. Now let's cancel this, and we will actually use gdb. Let's use this command gdb as heap 2, and let's see what happens. So okay, it is over here, and let's put a breakpoint on main function. So and let's run it. So I will use R, and it will take some time to come to that proper window. Okay, this is the PondDB's window. We can see the registers over here. Then this is the assembly, and this is the program source code. This is like stack, and this is call stack or backtrace. So let us do and till we reach our heap allocation function inside auth. So it will print. Okay, it is taking user input over here. So let's enter like OATH, sorry, AUTH, and here it will compare, right, that it is a the string contains auth or not. So it will call malloc, right, and authenticate this AUTH pointer. It will be the pointer to our newly allocated memory. So let's use this command to see the allocated memory, and you can see that this is the memory which is being allotted for our auth pointer. And now we can go back. We can simply type context. So we will go back to our UI, and then it will set memory to 0. So let's use n, and then it will compare if string length, if there are more, if the characters are less than like 31. So yes, in our case it will satisfy, so it will copy the string. And let's go ahead and see what is happening here. So we have actually you can actually see 0a over here. That's it. And let's go back to context. Okay, because we have not given any uh, bigger string. Okay, that is fine. So let's move next. So reset is not there, it will skip. Then service is also not there, it will skip. Login is also not there, it will skip. So it will come back to print statement, and it will print, and then it will again take user input. So now this time let's give what will give, let's give it reset, so that the memory will get freed. So okay, now if we do this, right, we need to go to reset. Yeah, it will free it over here. So the memory has been freed now, and if we do this, we can see that the Tcache bins is coming here. So this is the freed memory which will go to Tcache bins, and let's move back to context, and now it will again skip all the checks over here. So there is no login, there is no authentication over here, right? So it will again expect some string input. So now let's use service, because we have already allocated memory, we have already freed. And if you recall, looking at the source code, what service will do is that it will actually create a string loop. So we have freed up the memory, and we can see if we can actually use this. So let's give some data like a, and see if we get this memory allocated to the same location. So we are giving like less data than the actual allocation, actual allocated memory. So let's try. If not, then we will increase the size to 30 bytes, and then what will happen, our memory will be allocated to that freed chunk. I think this will not allocate memory over there. Let's see. So we will again go through. Okay, service, it has done string loop. So now let's see what happens. Yes, so actually this is our freed memory, as you can see over here, and the new memory is getting allocated over here. This is because we have given the bytes which are less than this memory. So what we can do now is that we can increase the character which we are giving to service. So let's do one thing. Now we again cannot go back here, so let's continue. We will again do auth space, it will allocate new memory, and then what we can do here is that we can actually reset it, so it will free up the memory, right? Let me show you by this command. So no, I think it's not working. Let's try again. Continue, and actually let's restart. Break on main, run, and let's actually run it by continuing. So let's use auth auth space. Let's try 1 2 3 4 5 6 7. Okay, this. So we can see that the memory has been allocated, and whatever data we have entered, it's copied to the uh, that particular variable inside auth structure. So let's do one thing. We will actually go back to context, and we will actually run it again. So let's run it, and let's write reset space, and if we can see if the memory has been freed or not. Okay, this has been freed, if you recall, right? 1 2 3 4 5 6 7 which we have copied, that has been freed. I'm not sure which visible. Yeah, okay, here. So this thing has been removed from here, the freed memory. You can see it over here, right? So this is good, and now we can continue, and what we can do now is that we can call service, and we can give a string which is like equal to 30 bytes. So let's type, or actually let me open another window, and we can use cyclic 30. So I have generated this string using cyclic. Let's copy the string, and we can paste it here. Yeah, this is fine, and now we can see that service pointer is over here. So interesting thing to note here is that if you notice over here, auth pointer and service pointer, you will see these two are pointing to the same memory. Authentication we have not marked as null in the code, and we have done a string duplicate of 30 bytes. So this address is same, and we can verify it using this command as well. So you will see that the uh, service option which we have given, right? We have given this string. This string is copied to the same location which was freed over here. You can see over here, and if we see the previous heap, you can see that it belonged to the cache bin over here, right? So the same memory has been reallocated over here, and this is why you should actually, after freeing the memory, you should set your pointers to uh, null, right? So now the thing is that we are able to use the freed memory here, and the thing is, how can we use it to control the execution? How can we print this particular message? So if you recall in the code, let me open that code over here. Yeah, if you see, what it is checking is that if authentication is there, and if we can actually uh, okay, it is actually, so this seems to be a different code. That is fine. It should be over here if I'm not, yeah, over here. So this is the code actually. This code is taken from Phoenix. So you can see that it checks for auth, and it also checks for if auth uh, variable inside this particular structure is set or not. So you can see that this is actually an integer variable, right? So what we need to do is that we actually need to set it to 1. And how can we set it to 1 is that whatever data we are giving to service, right, it is getting allocated to the same memory over here. So if we give the data which is of, like, say 30, more than 32 bytes, it will overwrite this memory location inside the structure, and that way we can actually uh, solve this challenge. So it will satisfy this condition, and we can see that we will see this message. So right now it will not print this message. If we do login, it will say that we need to enter the password, and it will again go back to that thing, right? So now that we understood the technique, like we can reuse the read memory, we need to move to the next step, which is how can we control the, like, memory structure. How can we put one inside that auth variable so that our checks is getting passed? So there are different approaches we can do. We need to figure out the uh, like address, that memory address. We can figure out the offset, and then we can write a single one uh, ASCII character over there, or we can simply write 111 to each and every memory location. So that will actually satisfy the check, right? So let's try this with the simpler approach. What we'll do is that we will actually allocate memory, we will free up the memory, and then when we call service, instead of giving any random bytes, we will fill it up with 11111, so that the entire memory will get occupied by 1, and then the check will be uh, satisfied. So let's try that. I will actually start this again, and it will take some time. So okay, let's click on main, we will run it and continue. So we will use auth 1 2 3 4 5 6, whatever. We can give anything after auth space, that doesn't matter. Okay, so we can see authentication pointer, we can also see service pointer is nil. Let's do a reset so that it will free up the memory. So we have freed up the memory in this case, and now we need to allocate a new memory using service. So service, and let's give 111 for, like, say 34 or more bytes. So 1 2 3 4 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 24 25 26 27 28 29 30 31 32. So 32 is for the name, 33 and 34, right? So this will actually satisfy the condition, hopefully. So yeah, we can see that the allocation has happened, and the authentication address and service address, these two are same. And let's verify it using the heap as well. We'll use this command. So yes, it's over here, right? So this was actually freed memory, and then it is occupied by 111. So this 111 is the ASCII string over here. Do not look at the hex over here, because in the code it is checking for ASCII 1, right? And now what we can do, we can see that so we have not filled this memory. We can actually give, I think, few more bytes. If this doesn't work, we will probably increase length to maybe 40 bytes. So let's see. We'll hit continue, and then I will write login space. So okay, looks like it worked. So it is already giving us the message that you have logged in already, right? So it means that the one which we have filled, right, it has actually worked. Now another approach we can use here is that we can like figure out the offset and only set that particular byte as 1. So let's try with that as well. I will actually cancel this. We will again start, and then we will see what is the offset which we can overwrite. So I think that will be the better approach. So let's continue. Okay, let's run it, and we will first allocate the memory. 3, 4, 5, 6. The memory seems to be allocated. We will free it using reset. Okay, and now let's see the width over here. So yeah, the memory has been freed. Continue, and now we will use service. So let's give this time, we'll give 32, we'll give 33, 34 bytes, right? So let's do one thing. We will use 31. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 31, and after that let's flood it with 1111. So we will see if actually 32 is the length, right? So 32, and then let's flood it with 1111, and then see what happens, right? So the address is same, and we will actually see the width. Okay, we can see that we have filled over here. We can give 3 more, but I think that will not be required in this case. So the thing we need to verify is that we have given 32 A's over here, which fills the uh, which will fill this buffer name, and then we need to overwrite. So we have given 2 more bytes over here. So that will actually become 1 1. So let's see what happens in this case, whether it's working or not. Yes, so it is working, right? So this is also we can use, and we can even like figure out the entire single byte over here which we can give and see if it can work or not. But that is something you can figure it out at your own. And now what we can do in this case, we can actually automate this. We can use a template from font tools template. Then let's give the heap 2, and we will output it to our exploit .py. So in my case, I have already created this. I have also uploaded it on my GitHub repo. If you want to like go and see where it is. Okay, it is over here. So you can actually use this binary. This is the compiled binary, and this is the exploit, right? So I will run it locally first, and I will explain the code. So this is a like a very simple Python code. We are importing everything from font tools, and then we are creating a ELF class over here which will give all the return address and everything, but we don't need in this challenge. And then there is a start function. Now what it will do is that if we have given gdb as argument, it will launch gdb, and if we have given like no argument, then it will simply launch this process. And then this is a gdb script. What it will do is that it will break on main function, and then we can continue. And over here we will call io is equal to start, and then initially you remember when we run this, we will get 2 lines, right? So it basically receives 2 lines, and then it will send line. So to send any data to this binary, we will use io.sendLine. We are converting it in like byte form. We will initially set like auth 1 2 3 4. It will allocate the memory. Let me comment it over here for malloc call. Then we will call we will use io.sendLine, which will use reset. So what it will do is that it will actually free the memory, freeze the memory, and then we will call service, right? So what it will do is that it will actually reallocate memory to freed location if length is proper. It means that you need proper length. If you give smaller length, then it will not allocate. And then we will call login, right? So we are simply sending ASCII strings over here, nothing specific in a sequence. And this is how, and then we are doing IO interactive. So let's write it and let's run this and see if it works or not. So exploit.py, okay. And you can see that we got the message that you have logged in already. So it means that this script is working fine. And now one more thing we can do, we can actually give GDB as argument and we can debug the code if required. So it will actually open another terminal and yeah, let's continue. So it has actually sent auth 1234. As you can see, it will do a malloc mem set to 0, then it will copy that the data, then it will call, I think reset will not work, service will not work, login will not work, then again it will send reset. So this will free up the memory over here, right? So we can do this and we can see that cache bin is here. Let's go back to context. And so what I'm doing is that I am running the Python script. So all the data will be sent by the Python script. We are simply debugging it to see that everything is working fine. This approach you can use when you want to debug the script, when you want to make sure that everything is working, or if you want to fix some issues. So let's click on next. Now third time it will give reset. Yes. Oh, that time it will give service, right? So it has given service. Okay, it has copied the data, and if we see, okay, it's already 111 here. So we will move back to context and let's do next. So fourth time it will send login. So yeah, you can see the parameter over here. So let's do, okay, it will go inside login and it will actually check. So let's print auth. You can see that it is still pointing to the same our structure, and let's print the auth variable. So let's print in hex. It is 313131. So it means that it is 1 over here. It has some value, right? So it will actually work. And then if we do next, it will actually printf. You have logged in already. So it means that our code is working perfectly fine. And this is how we can solve this Protostar Heap 2 challenge. In next video, we will see how can we solve Heap 3 challenge, which is a bit on the complex side if you are not familiar with CTFs and all, or if you have not done Higgs exploitation. So we will see that how can what is the heap structure, how can we use Erlang exploit, and how can we solve that challenge. So till the next video, stay safe, enjoy, and please do not forget to subscribe, like, and share my challenge, my channel. If you have any question or comments, feel free to post it in the comment section. That will motivate me to take more such videos. So till the next video, goodbye and thank you.